Okay, so I'm going to be doing the 6.6 quiz for physics. The rest of the questions are sections are really easy, so and they're all memorizing from the book, so I can't really do them. Okay, so a fixed amount of gas kept at a constant temperature has an initial volume of blah 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 and a pressure blah blah blah. This is Boyle's law, by the way. Make sure to memorize like all the laws. Anyways, the formula for this is going to be P1 V1 equals to P2 V2. Pressure 1 is 120 times volume 1, which is 3, equals to pressure 2, which we're trying to find, times volume 2, so 4. That's going to be 120 times 3 divided by 4, and you get 90. Moving on. Okay, so a fixed amount of gas is kept in a rigid vessel. The initial temperature of the gas is that. Okay, so the formula we're going to use for this is uh, P1 over T1 equals to P2 over T2. And you're going to like recognize which formula to use, because here they gave you pressure and temperature, so you're going to use this. If they give you like pressure and volume, use the other formula, or temperature and like whatever, like you have to like know how to recognize it. Anyways, pressure 1 is 280 over 300, make sure it's in Kelvin, which it is, equals to pressure 2, which is 180, over the temperature 2, which we're trying to find. Cross multiply, that's going to be 180 times 300 over 280. You get, let me just write it really quickly. You get 192.85. They wanted to one decimal place. So to this, but there's a number for it that's 5 and above, so you're just gonna add 1, so 192.9. For this question, we're gonna use PV equals nRT, and you need to know that the volume has to be in meters cubed and pressure has to be in pascals. Okay, and temperature has to be in Kelvin. So the pressure here is 8.50 times 10 power 5. Wait, okay, so we're looking for the temperature. So let me rearrange this formula. So the temperature is equal to PV over N times R. So temperature is going to be pressure, which is 8.50 times 10 power 5, multiplied by the volume. The volume here is in liters, not in meters cubed. So we're going to convert it. Liters to meters cubed is divided by 1,000. So it's going to be 4 times 10 power negative 3. Divide that by the moles, which is 3 moles, times R, which is 8.31, and you get 136.2, rounded up is 136. So here, a fixed amount of gas is kept at a constant pressure. The initial temperature of the gas is blah blah blah. Again, you have to memorize it. They give you volume and temperature, so just do V1 over T1 equals to V2 over T2. So volume 1 is 2. Temperature 1 is 300 equals to volume 2, which is 1.2, over temperature 2, which we're trying to find. Cross multiply 1.2 times 300 divided by 2. You get 180. So basically, in this question we use PV equals nRT. We're solving for pressure, so pressure is nRT over V. So let's replace everything. 0.18 is the moles, multiplied by R, which is 8.3, multiplied by the temperature, which is 300 Kelvin, over volume. Now the volume here is in centimeters cubed. We're gonna convert it to meters cubed. So we divide by 10 power 6, which is like 1 million. So 10 divided by 10 power 6. You get P to be 4482000, but pascals, obviously. But here they're asking for M pascals. So pascals to M pascals is oh, pascals to M pascals is dividing by a million. Okay, so we're gonna divide by 10 power 6 again. So divide 10 power 6, you get 44.82. They want it to one decimal place, so it's just 44.8. So for this question, it came actually the exact same numbers in EMS. But anyways, uh, the modern soda can hold beverages at blah 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 blah. Here we have a correlation between pressure and temperature. So P1 over T1 equals to P2 over T2. Pressure 1 is 600 over temperature 2. Temperature 2 is in Celsius, and we never saw the formula with Celsius. You have to convert it even though this is in Celsius. We do that at the end, okay? So 20 plus 273, okay, is 293. Oh, no, sorry. We're trying to find this temperature. We equal it to 300 over T2, which is 293. These are like paired together. This is like a 1, okay? Cross multiply 600 times 293 divided by 400. You get, let me like write it down. You get 586 Kelvin, okay? But they want it Celsius. So instead of adding 273 like we usually do to convert Celsius to Kelvin, we minus 273 and you get 313. Okay, this question is not that complicated. It's like a lot of like thinking into it, but like it's fine. So a fixed amount of gas at pressure P, volume V, and temperature T. So that's P1 V1 over T1 equals to P2 V2 over T2. So you have to read the question carefully. It says the pressure of the gas has doubled, right? That means the new pressure doubled, and they said the volume has tripled. So the new volume has tripled. What is the new temperature? So let's write it down according to what they told us. So 2P2 3V2 over T2. Wait, actually I need to correct something. Here we put, after we put the 2 and 3, okay, you have to put P1 and V1, not P2 V2, because they said the pressure of the gas has doubled. So the pressure doubled is double the initial. So that's what we mean when we do this. Same thing here. The volume is triple the initial, so it's 3 times V1. Okay? Meaning now you can cancel these out. But before you do that, let's simplify. 2 times 3, 6. So P1 V1 over T1 equals to 6 P1 V1 over T2. What's the point of doing all this? The point of doing all this is to solve for T2. So what you can do is you can cancel P1 V1 here and P1 V1 there. So you get 1 over T1 equals to 6 over T2. What you do here is you cross multiply, okay? You get T2 equals to 6 T1. So that's the answer. So there's two ways of doing this. There's a really fast way and there's like a bit like slower way, but it's like the same thing, okay? So here they said the temperature of the gas is halved. What is the pressure? We know that temperature and pressure are directly proportional, right? So if the temperature is halved, the pressure is gonna halve too. What's the pressure? The pressure is 120. 120 divided by 2 is 60. That's the first way. The second way is to do the formula, which is P1 over T1 equals to P2 over T2. Pressure 1 is 120 over 600 equals to pressure 2, which we're trying to find, over temperature 2. They said the temperature is halved. Okay, so we're gonna half 600, so 300. Cross multiply 120, x equals 120 times 300 over 600. You get x to be 60. Okay, so here they gave us the temperature and volume, so V1 over T1 equals to V2 over T2. Volume 1 is 2, temperature 1 is 300, volume 2 is x, we're trying to find it, over temperature 2, 420. Cross multiply 420 times 2 over 300. Let me put that on my calculator. You get 2.8 exactly. So yeah, moving on. A gaseous system, whatever. Okay, we have here volume and temperature. Okay, that's V1 over T1 equals to V2 over T2. Volume 1 is 3, temperature 1 is 350 equals to volume 2, which is x, over temperature 2, which is 550. Cross multiply 3 times 550 over 350. Let me do that. You get 4.7. They wanted to one decimal place, so it's just 4.7. And that's it for 6.6.